Bella raga, today I'm going to take you through the process of restoring my new to me mill machine. Didn't have a lot of things to do to it, but some stuff had to be done in order to make it fully operational. Unfortunately, this is the price to pay when you purchase a used milling machine or any machine in general. So let's get to it, and let me take you through what needs to be done. Let's go. So this is the milling machine that I purchased of a gentleman about an hour from me. It is an old jet vertical milling machine. It's a bench top, but it's I think the smallest knee milling machine that you can find. This milling machine was used exclusively to process wood, so it was every nooks and cranny was completely covered in wood dust. So I went through the process of removing all the wood dust from everywhere, and as you will see in the next clips, there was a lot of surface rust, but luckily it was very shallow, so I managed to clean it completely and very effectively without removing any actual material from the waste and the table. But one of the main things it was up there. So this is the pulley cover. So the main thing is the drawbar. Instead of having this nice nut that I fabricated, had two small nuts that you had to operate with two wrenches in order to get it to the correct distance from the spindle, from the collet or whatever you're gonna put. And I don't like you having to use two wrenches because it takes more time. So I took the drawbar out. I removed the two nuts. The top one was welded, so I just skimmed it on the lathe, and that removed the weld, took the nuts off, and I ended up fabricating this, and I am only using one wrench, and the wrench lives right here on the side of the milling machine, and it's very comfortable for me because I just pick it up and operate the drawbar. In order to make a new nut for the drawbar, I ordered this 3/4 inch cold rolled hexagonal stock from McMastercard. Being cold rolled, it holds tighter tolerances on that 3/4 inch. So let's talk about the proper machinist way to make a nut versus the way I made this nut. The proper way being using a round stock, putting in the lathe chuck, and then facing it, drilling a hole, threading it, putting on a collar block over on the milling machine, and milling the 6 sides on a very precise dimension. Now I cannot use my milling machine, being this one that I'm making one of the main components to make it operational. So I have to rely on the shape and size of the hex stock to be able to make a proper nut. Luckily this is cold rolled, so like I said, it's precise enough to make a fully functional nut. So let's start by facing the stock, which is always the righteous thing to do. Then I'm going to punch a center with this number 2 center drill. Then I'm going to start with a pilot drill. I think this is a 316 drill. And this is the tap size for 1/2 inch 12. I did some intermediate passages, but I didn't include them here because I didn't want to bore you all with all of the same content. And here is the infamous 1/2 inch by 12 tap, which I order obviously from McMaster-Carr. The usual coarse thread for 1/2 inch is 13, but it's not uncommon to find on import machines this 12 toothbridge, as per one of my neighbors who professionally repairs all sorts of machines from manual to CNC. And even if it's not a machine, you can see the 3/4 inch socket wrench grabs it nice and tight. And here is Loctite it in place and pinned it. The table had a lot of surface rust, which cleaned up really nicely with a lot of WD-40, steel wool, Scotch-Brite pad, and a lot of elbow grease. I also had to make this key for the nut that holds the spindle pulley. So the reason why I had to take the spindle pulley off is because when I went to pick up this mill, in order to make it fit inside the van that I borrowed, we had to tilt the head 90 degrees. Now, unfortunately, this mill is not made for that kind of tilt. It only goes to a maximum of 45, so the 90 degrees made it stick to that position, and the only way that I had to put it back on its original configuration was to take the head apart, which meant taking both the pulleys off, the pulley cover, which links both the front and the back of the head. And once I did that, I managed to take both the front and the back of the head off, unstuck the bolts, and put it back in the original configuration. So this machine has a round column that is made in 2 pieces to swivel the head this way, which I don't see the point of doing in my case, because I'm just going to make folding knives. You can see this bolt is completely stripped, and this one just spins and spins and spins and more spin and more spin and more spin, but you can see it did not move vertically at all. So this is completely stripped, and I'll probably have to cut it, although I do not want to use a cutting tool here and risk to nick this the casting, which could cause a crack when I tighten it down. I have to tighten this pretty hard because I don't want the head to swivel under when I use the fizz mill. So I'm going to try and drill this way, and then chisel it out. Maybe we'll see what happens. And these bolts are good, but since I'm taking the head off, I'm going to change this to avoid. So I bought high strength bolts, heat treated, so this will not happen. I was thinking to put stainless steel, but I'm worried about galvanic corrosion between the stainless steel and the cast iron. I don't know if it's a thing, but I did not want to risk it, so I got the carbon steel ones. So the first thing that I'm gonna do is to put my chain hoist attached to the rafter. It's a very inexpensive chain hoist, 2 tons from Harbor Freight, and strap the head on, so when I start taking the bolts off, the head doesn't fall on. So as you can see, the chain hoist is not aligned because the rafter is a little on the right side. It's not gonna be too much of a problem though, because I have enough slack with the slings. And that's it. I might move it though. Might move the milling machine so it's right under in case I need to service it again. I'm going to try and drill out and drill this a little hole here with this 1/8 drill bit, and trying to enlarge it until there is just a little webbing, and then trying to chisel out, or maybe it will be enough to take it off. We'll see. More or less in the middle. The number 2 center drill, a little on the weird side, having the tripod in the middle. Right, I think I'm through. A little bit of cutting oil on the drill bit. I think this is a little too big, but all right. Let's see if it comes off. And that's it. As you can see, this bolt is stripped. It's completely smooth on the bottom side, and also this one same, and the last one as well. It's not super stripped, but that is the threads are not really good. It was hanging on, it was tightening it, but not too bad, too good. So I'm changing all three, and I'll change this one as well, even if these are tight, but I don't want to actually have any trouble in the future. I am using gloves and a jacket because this chain is obviously very bulky. And bolt 1, bolt 2, and bolt 3. I'm going to give it a nice clean. So I couldn't measure the bolts before, and the new ones are a lot longer, so I'm gonna go cut them. So I lowered the head back on just because I don't want the rafter to hold the weight of the head is pretty heavy, and it's right at the end of the rafters. See, there isn't, I don't know if you can see, there isn't a lot to hold on, so I want to make sure that it was held a little bit by the base of the mill. I swear to God, these inexpensive chain oils from Harbor Freight saved me so many times. See how easy it is to lift the head of the mill, and take into consideration that the head must be weighing more than 200 pounds. It's very heavy, and yeah, no effort whatsoever for only $85. And that's it. Now I just have to do the top one, and then I'm good. And there it is. All the bolts have changed. High strength, you know, heat treated bolts. This was kind of a pain because it's right behind the spindle. And that's it. So before using the milling machine, I have to do 3 things. One is very important, is the chip cover. There was one here. I took it off because it's really worn out. I have a piece of leather that I can use. It's way thicker than this, but I can skive it to make it thinner, and mount it on the milling machine. The second thing is a lock for the Z-axis. It was broken. Managed to take it out, and I am going to make one. There's another thing that is very important. The third thing is the lock for the cover, the pulley cover. This I can do it later, but I want to make one, and also make probably a knob to be able to actually hold it. But this I can do it later. So let's go make the chip cover first, and then I am going to make the lock. So I positioned the old chip cover, not cheap, chip, on the piece of leather with very heavy weights, so it lays down nice and flat. And now I'm gonna trace it. And it doesn't have to be super duper uber exact, just needs to cover the ways. You can see how it's literally falling apart, the old one. I apologize for the shakiness again. My tripod is very flimsy. In order to avoid stressors, I'm gonna punch holes on the corners. This is an old punch that I bought in Italy. It works very well. The trick for using a hole punch and make it last very long is to use another piece of leather or any soft material. It could be a piece of PVC under the hole that you're punching, so the punch does not touch the brass, and will last way longer. I'll just hit my elbow. Of course, the thickness of the leather that you put underneath will offset the angle, so you have to kind of feel where the punch is nice and square, and you got your hole. And of course, I didn't remember that I had a nice piece of leather that was a little thinner than the one that I usually use for sheaths. And I'm going to be able to avoid skiving it, even if it's slightly thicker than the previous chip cover, but I'm gonna thoroughly oil it with the oil that I use for the machines, so it becomes nice and soft and it will bend very nicely. Here we have it. I could round the edges, but well. So this is the way cover. Let's go mount it. So this is the top one. The holes look nicely aligned. Now the thickness of the leather will make it a little difficult to start the threads. But then it will compress. And the most observant of you guys will notice that this is not the same piece, because it looks like that the old one shrunk quite a bit, and therefore the one that I made model after that was way too short. So I had to cut a new one. And that's it. Found the thread. Here's the chip cover. I'm going to oil it so it will bend nicely, and that's it. All right, as of right now, I can make the first chips. I was more worried about the chip cover than the Z-axis lock, because being a knife maker, I'm gonna have to work on wood on this milling machine as well, and I don't want all that stuff to go on the ways, and also I don't want metal chips to go and lay on the horizontal ways of the y-axis. Well, anyway, I'm going to make the z-axis lock in another moment, because now I'm out of time. I have to start working. But as of right now, I can work on this mill. I am waiting for the jaws for the vise, and then I'm going to be able to start working. One quick service announcement: I'm going to start a Patreon soon, because I want to keep making these videos, but the rent is here is becoming more and more expensive, and if I make the videos, it for me will take a lot longer to produce anything, and since I work only 1 day a week in this shop, that will make it not conducive of a good business. So if you guys can spare a few bucks, it's very appreciated. I'm going to have stuff available for the patrons. I still have to make up all the details, but I'm going to have quarterly either gifts or giveaways for the patrons, and that's it. Don't forget to like and subscribe, and Ciao tutti. Bye bye.